Okay, we are looking at the properties of water lab, and what we are going to be doing is investigating some of the strange properties that water exhibits, and we have some reasons why water is so unique and has some of these traits. And so as we go through some of these observations, it's going to be your guys' job to make those observations and then to explain them the best that you can. So we're going to start by taking a look at water and a paper clip. So if we just take a paper clip and we just put it in the water, now you'll notice I'm holding it on edge here. If we just take the paper clip and we put it in the water and we're holding it on edge, the minute that I let go, we can see the paper clip has sank to the bottom. We see it at the bottom there. Now, if we're a little bit more gentle in how we set the paper clip in there, let me get another paper clip so I don't have to fish that one out of the water. But if we're a little bit more gentle in how we set the paper clip in, instead of putting an edge on, if we turn it sideways and we set it down so that it's perfectly flat in the water, and it's okay even if we get our finger wet when we do this, we're going to set it gently into the water. So you'll notice that we get a very different result here. So now, in this situation, we see that paper clip staying right on top of the water, while the other one sank down below. And if we look, you can almost see like it's making an indent in the water. You see as we kind of go back and forth, you can see it reflecting there. If we lower it down a little bit, you can see that, let me see if I can get it lower here. You can see that the paper clip is actually below the surface. So if we get a little bit closer here, we can see that paper clip is below the surface, but it's not actually sinking. Okay, so we want to know how this is happening. Why when I put it in one way, it doesn't work so well, and when I put it in the other way, it does. Now, you can try and do this with a larger paper clip. I have a larger paper clip here, and let's just get this guy out of the way so we give him a little push and that one will sink. You can try it with a larger one, and it doesn't really like to work. We can see that it almost wants to go, but I can't get it to actually... almost. It wants to go, but it just doesn't quite make it. Occasionally, if you have a super flat one, you can get it to work, but for the most part, they just sink down below. So those are our first observations there, where we are looking at the small paper clip and the large paper clip. What did we see happening there? Okay, for the next part, what we're going to do is we are going to take a little bit of oil and place about a quarter-sized spot on top of the water. So for the oil, we're just going to be using some vegetable oil there. And I'm going to use a pipette to suck a little bit up. And we're going to put about a quarter-sized spot in the middle here. And we're just going to kind of observe that oil. Okay, so we see the oil tends to be sticking together quite nicely. You notice that when I put it off to the side, a lot of times it was drawn in. This one's kind of getting stuck right there. But now at this point, it's just pretty much sitting there, just stays right on top. And now the next thing that we want to do is add a little bit of detergent to it. We're going to put a couple of drops of detergent right in the center of the oil, and we want to see what happens when we do this. So let me get some soapy water here, that's detergent, and we're going to put a couple of drops. Now watch closely on the oil here. One drop, and then boom. Right? We see what's happening here. Okay, so what's starting to happen to the oil in the water once the soap has been added? For the next part, what we're going to do is we're just taking a regular penny here, and I've just set it on a paper towel. And what we're going to do is take our pipette, very similar to what we were using to spread the oil. And we're just going to be taking a little bit of plain old pure water. And what we want to do is count how many drops of water I can fit on the penny with pure plain old water. All right, we're gonna recreate the same thing now, but instead of using water, we're going to use detergent, so soap. And once again, we're just gonna go ahead and count how much will fit on top of the penny. Looks like it's starting to fall off now. I see those last couple of drops, they weren't sticking. Every time it hit, it falls off. So we'll stop there. I mean, but we'll see if we put another one on, it should just slide right off. Yep, just sliding off. So it's not holding anymore. That's all it'll hold. Okay. The next part, what we're going to be using is a bunch of little glass straws called capillary tubes. So basically what we see here is a little glass tube. This is what we're going to call the large tube. The next little glass one we have here is what we're going to call the medium tube. And so if we look at those inside diameters here, we can see that one is quite a bit larger than the other. And then we have one final one, and we're going to call this one a small tube. So we can see that it's getting smaller and smaller and smaller in terms of the inside diameter. So now this last one is basically that the walls of that are basically the thickness of like maybe a piece of paper or something like that. So for this one, what we want to do is take these capillary tubes and we want to put them in water. And we want to try and see which one is we're able to observe the most capillary action in. So let me get a little beaker of water here. And there we go. And so what I'm going to do, maybe just so that we can see it a little bit easier as it goes up the things, I'm going to put a little bit of food coloring in here just to make it a little darker than the background. So let's stir that in. Okay, so capillary action is basically the spontaneous movement of liquid up a tube. So we're going to go ahead and we're going to set this inside, and you'll see that when we look at it here, so if I touch it against the side, we start to see some capillary action just between the glass, between the beaker and the tube, right? So as you touch it, it's almost like the water's being squished up the side, but we want to actually see what's happening inside. So, right, see when I start to pick it up, we start to see that there's a little bit of capillary action there, right? It's kind of staying above the surface of the liquid a little bit. So if we pull it out, we can see that some of it stays in there. That's our capillary action that's going on, right? How is that staying in there? So let me get a ruler. See if we can measure it. So what we'll do, just to kind of keep them all equal, is we'll take it out and we'll sort of just hold it up next to the ruler here. And see if we can't measure the height of that. So what do you guys think that is in terms of height that the liquid's able to draw up the tube? Okay, so that's the big guy. Let's go ahead and try the medium one. So we'll take the medium one, we're going to dip that guy down in. And let's see what kind of capillary action we're getting with the medium. And now let's go ahead and try it with the little guy. So we'll go ahead and submerge this one. We'll pull this one out. Do my best to get that lined up. Go ahead and take that measurement. And for our final piece, what we're going to do is come over here to the plastic dish. We see in the plastic dish there's some grooves in it, and we're going to use one of those grooves. So what I'm going to do is I'm just going to go ahead and take some of the water and I'm going to fill up one of those grooves rather than fill up the entire tray. Okay, so we have the water filled in that center groove. We can see it coming along the line here. And then at the bottom of the lab, we have, so on our data table side, when we flip that over, we see that I've got a little rocket looking thing here. And the instructions would have told you to go ahead and cut that out. So we're gonna go ahead and cut this thing out real quick. Normally somebody in the group would sacrifice the bottom half of their paper here. So we're just gonna get that thing cut out real quick. And then we just need to get this notch out right here. It didn't photocopy well, but that's supposed to come out. Okay, so we've got something that looks like this. And what we're going to do is we're going to go ahead and float that in the water. And then what we do next is we take a little bit of our soapy water here. Let's put it on the other side there. So we take a little bit of that soapy water and we're going to put a drop right back here in the notch. So we'll float it. So the boat is floating right on top of the water. We go ahead and we take a little bit. We're going to put one drop. That's all we need, one drop. There we go. Now, if we try and do it some more, if we move this guy back, hey, move back, you'll notice that it doesn't work. Well, a little bit. All right, not so much though. It only works that first time. Once it's traveled the length, it doesn't work anymore. It doesn't really want to move. So we're going to try and explain why when I put one drop in that little notch, that thing took off, right? You'll also notice what's happening over here. The water that was in that groove is starting to spill over. And that happened after I put, what, 3 or 4 or 5 drops in? Doesn't seem like it should be enough to fill up that entire groove, and that's related. So we want to think about what's happening that could possibly, what that one drop was doing when it fell in that notch that would send the boat racing down the channel.